In this video, I'm going over average and instantaneous rate of change. So here with the review of our average rate of change. So again, we're just talking about slope. So in the past, what we're familiar with, right, with our slope is, so our review is we have our change of our y, so y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So again, we're just talking about average rate of change, which is our slope. Now here, you could also write this as the change of y. So this symbol here just represents our term for change over change of x. Now, we'll also we could see it a different way, and we'll talk about this third format in a little bit here when we get into the instantaneous. So again, we have change of y. So if you recall, when we're looking and talking about our functions, so like for example, f of x is equal to what value, right? When we plugged in our x value, then we always got our output, which is the y value. So f of x is the format for our output, our y. So again, we're talking about the distance between 2 points, right? So like, let's say the values are A and B, right? So just two values on the grid. So another way of looking at the change of y is our y value, remember, is so is f of B minus f of A, because this is our format for our change in y, over our x's, which are the values that we would be substituting in. So B minus A. So keep in mind this format here, and then we're going to come back to that in a little bit. But let's go ahead and let's review our average rate of change. So again, we are just focusing on the change in y over the change in x. This is our average rate of change. So we're talking about functions that are not necessarily linear. So like here, if I want to know what's the average rate of change over the interval from 2 to 30. So here, my x values are 2 and 30. So that means we need to first figure out our change in the y values, which are our f of x. So in this case, 7 and negative 2. So 7 minus negative 2. That's our y values. Then over our change in our x, which is 30 minus 2. So here, that's how we get the average rate of change over the interval. So 9 over 28. That is the average rate of change. Let's go on and pause the video and try this. You try on your own. And here we go. So you just had to focus on, you just had to focus on the average rate of change over the interval from 0 to 7. That's our x values. So from 0 to 7. So your y values, right? The change in your y's are 5 and 3. So here, 5 minus 3 over the change in the x, 7 minus 0. Our average rate of change is 2 over 7. So now here, we're making sure that we get our equations. Now we're given the x values, so we're going to need to substitute, right, to get our y value, the f of x. So here, we're going to need to find f of 4 and the value of f of 1. So here, if we go back now to this other format where we have our function, we need to plug in and substitute here f of b minus f of a, right? That's your change in y. So here we have f of 4. So what we're looking for here is we're looking for what is f of 4 minus, my pen here. There we go, minus f of 1 over the two values, which are in this case 4 minus 1. So now we've got our function, the natural log of 3 times x. So we're going to substitute that in. So here we're looking for the natural log of 3 times 4, which is 12, minus the natural log of 3 times 1, which is 3, over 4 minus 1. So that is representing our average rate of change, which is approximately 0.462. So I'll take that to 3 decimal places. Go ahead and pause the video and try the U-try on your own. And so here with our average rate of change, you needed to first get your change in y's, right? So we need f of 5 because this is our x values. So we know we have our function over the change in the x's, which are 5 minus 2. So we need the value of f of 5, and we need the value of f of 2, which again is substituting. So here you have 2 times 5 squared minus 3. Here we have 2 times 2 squared minus 3. Again, we are substituting to get our output. So here, when you substitute, you should have gotten 47 minus here, when you substitute, you should get 3. Or no, I'm sorry, not 3, 5. And then when you solve, your average rate of change is 14. So last with average rate of change, we're going to look at our graph, again, over the interval. So from -5, so -5 to -2. So when we're looking at average rate of change of a graph, we're basically almost creating the, to find the average rate of change is like we're finding the slope, but of a secant line. So if you recall, a secant line, like on a circle, cuts through the circle at 2 points. So we're doing that here with the graph. So like here, for example, what is my output at -5? 2. So my y values are 2. Is here, and then at -2, it's at -1. My function, my output's at -1. So basically, we are creating and finding the average rate of change of this secant line here, right? Cutting through our graph. So again, the change in y's are -1 minus 2 over -2 minus -5. So again, the change in the y's over the change in the x's. So here we're at -3 over 3, which is -1. And you could also technically check here, right, with our graph, because this is rise and run. So the rise is 3, the run is 3. Notice you have a negative slope. There it is. So same thing here. We'll do another one. So again, average rate of change is the slope of a secant line. That's what we've been doing here. So the x values are -1 and 5. So here our output, our y values are -1 is here at function of 2, and 5 has an output of 5. So here again, change in y's, 5 minus 2 over the change in x's, 5 minus -1. Because notice, we are finding the slope of this line here. We're cutting through our graph, the secant line. So this is 3 over 6, which is 1/2. Again, notice slope of our secant line. So go ahead and pause the video and try the U-try on your own. And here we go. So again, here, for x value -4, you have your output of -1. For -2, you have your output of -1. So the average rate of change is 0. You should have gotten 0. From -1 minus -1 over -2 minus -4. And notice you have a flat line. There's no rise to it. And you have 0 over 2, which is 0. So now we're going to get into the instantaneous rate of change. So first off, again here, just to show you, when we're talking about slope of the average rate of change, we're talking about slope of a secant line. So just to show you guys an example here, when we're now looking at instantaneous rate of change, we're focusing on the slope now of the tangent line. So if you recall with circles, the tangent line only intersects the circle at one point. So like notice here, if I wanted to know the average rate of change from this point to this point, then we would have our secant line going through 2 points. But now instantaneous rate of change is the slope of a tangent line at 1 point. So here, like our x and y, our x and f of x. So notice how if I want to know what's the instantaneous rate of change at this 1 point, it's like we're taking and finding the slope of this line here, the tangent line. So like this has an instantaneous slope of 1. So again, this is our instantaneous. So here, our instantaneous going through the 1 point is negative 1/3. So again, slope of a secant line. So I'm going to go back to that function. So remember, y can also be represented by our f of x. So here, we always have our values. So like we talked about the f of b minus f of a over the two x values, b minus a. So now I'm going to substitute b for x plus h. Now, h represents the change in x. So h is just another way of representing your change in x. So this is still representing our f of a. So our f of b here. So this means, again, b is going to be substituted by x plus h. So we're going to now take and focus on our variable x here. So another way of looking at slope of a secant line, this is f of x plus h minus f of x, that's your change of y, over x plus h minus x. So again, substituting the b value with x plus h representing your change in the x value here, and overall change in y. So that means now, guys, our slope for the tangent instantaneous rate of change is, now we're focusing on, because it's the 1 point, we're going to be focusing on the limit as our h, because of the change. If you recall, notice how, is there another point here? No, we're just focusing on the 1 point. So in the end, our h value, the change in x, because that's the only one, is approaching 0. Then we have our function f of x plus h minus f of x over x plus h minus x. So now notice, though, in the denominator, we can simplify this because this is just x plus h minus x. Well, what's x minus x? 0. So this limit, as h values approach 0, right? You're changing your x because there is no change in x. As approaches 0 is f of x plus h minus f of x over h. So notice here we're going to have to be simplifying because we can't substitute in 0. Now, just to show you, this could also be seen as the limit as, because remember, h is the change in x. So here we're focusing on the change in x is 0, and f of x plus the change in x minus f of x over the change in x. Now we're going to focus on this format here, though, today. So now just to show you how we're going to find the instantaneous rate of change. Let's say here, for our function x squared, where x is -2. So here we're finding the tangent. So notice how we're going to end up having to get a negative value, right? So here we're focusing on that instantaneous rate of change going through our x value at -2. So we're going to focus on the limit as our h, our change in x, approaches 0 of f of x plus h minus f of x over h. So here, now we're going to have to substitute x plus h into our function, which is x squared. So now I've got x plus h squared. This represents your x squared here. So substituting x plus h in for x. So now it's x plus h squared minus, we substitute, well, it's just still x. So x squared. So it's just the function f of x, which is x squared minus h. So now notice we need to start substituting because this is x plus h squared, which is x plus h times itself, right? X plus h. So I could do FOIL or box. So here I'll go ahead and do area model here. So x plus h times x plus h. Now again, if you're FOIL, go for it. So I've got x squared, h times x, and h squared. So here to combine like terms, after combining, we've got x squared plus 2hx here plus h squared from FOIL here, or box method, minus x squared over h. Now here, notice I've got x squared minus x squared. That's 0. So now I've got 2hx plus h squared over h. And then now notice here, we have a common term that we can factor out. We have h. So h, after factoring out, we only had the 1, so now it's 2x plus just h here, right? Because we had 2, we had h squared, take out h. Now 2x plus h over h. Now h divided by h is 1. So all we have here now is 2x plus h. Now keep in mind, this is instantaneous, so this is the limit as h approaches 0. So now we can substitute, because before, right, remember, this would give us an undefined. Now we can substitute h with 0. 2x plus 0, which is 2x. And so now here, when the x value is -2, right, because remember, x is -2. 2 times -2, because x is -2, is -4. That is the instantaneous rate of change. So here, show and do another one. Let's find the slope of the graph, instantaneous, of 4x squared plus h, where x is 0. So keep in mind where x is 0. So again, we're focusing on the limit as h approaches 0 and f of x plus h minus f of x over h. So here we need to substitute x plus h in for x. So this is 4 times x plus h squared plus 1. That is our function, the f of x. We just substituted x plus h in for x. Now minus the f of x function, which is, what is f of x? 4x squared plus 1. Now notice, keep it grouped together in parentheses because we're going to have to distribute over h. So now, here we go. We've got, notice, box here, And then I'll just go back. We actually just did that. X plus h times x plus h. So here we've got 4 times x squared plus 2xh plus h squared plus 1. Now we're subtracting, so distribute the negatives. So minus 4x squared minus 1 all over 8. Here we go. So now I can distribute. So this is 4x squared plus 8xh plus 4h squared from multiplying, distributing 4 plus 1 minus 4x squared minus 1 over h. Now here, I've got 4x squared minus 4x squared, canceling out. I also have 1 minus 1, which is 0, canceling out. So now here we got 8xh plus 4h squared over h. Now notice we have a common factor of h. So once you divide h out, you have 8x plus 4h, right? Because again, you had h squared over h. Now divide out, h divided by h is 1. So I've got 8x plus 4 times h. Now keep in mind, this is the limit. There we go. Limit as x approaches 0, where x is equal to 0. So let's go through now and we can substitute. So this is 8 times 0 plus 4 times 0, because our limit value, h, is 0, and our x value is 0. So here that means our instantaneous rate of change is a flat line of 0. So if we wanted to know where x is equal to 1, same thing, right? We've got the limit as x approaches, I'm sorry, not x, as h approaches 0, but now where x is 1. So again, we had 8x plus 4h. So this is 8 times 1 plus 4 times 0, which here now you get the instantaneous rate of change of 8. So now I'm going to just show you another way we can go through this process. Instead of substituting our value of 0 at the end, substitute it with the function as we're simplifying. So again, we're focusing on limit of our function as h approaches 0, f of x plus h squared minus f of x over h. So here again, we're going to substitute our x plus h, right, in for x. So this is 4 times x plus h squared minus, again, our function, which is 4x squared plus 1 over h. So now, let's go ahead and you can also substitute now x with 0. So here I've got 4 times, well, 0 plus h is just h squared. So 0 plus h is just h, so h squared. Minus, well, 4 times 0 squared is just 0. Plus 1 is 1 over h. Oh, I just realized, I'm sorry. I forgot to put the plus 1 here. I apologize. So that was 4x squared plus 1. There we go. So this is 4h squared plus 1 minus 1. So now notice here, right, because we got 0 plus 1, which is 1. That is 0, canceling out. So here I've got 4h squared over h, which simplifies to 4h. So here we go. The limit as h approaches 0, substitute 4 times 0, which again is also, there's your 0.